The next topic is about the relational operation. Relational operation compare the element of two array and return the logical value, the logical true or false, or 0 or 1, or true or false. For example, suppose that it is an array and you want to find the value that are greater than 5 or greater than 5. The result is a logical array. The places that are greater than 5 are 1 and the other place that lower or equal to 5 are 0. The logical operator in MATLAB are double equal that determine equality. The next is greater than or equal. Next is lower or equal, greater, lower. They are the relational operator, and the next is inequality. There's a inequality in operation. For example, find the value in R that they are not 6. 6 is 0 and other element are 6. Find the value that are equal. 6. 6 is 1 and other element are 0. You can apply this operation to a matrix. For example, it is a matrix and you can find a value that are greater than or equal to 5. Two value. These value are greater than 5. Suppose that you want to modify this value to a new value. For example, find a value that are greater than 5 and convert them to 5. How can we apply it? So we must find the value are greater than 5 with this command and then use the logical indexing. Logical indexing is the output of relational operation. So we write b, and b is greater than equal to 5 to 5. So this value are changed to 5. This operation is very useful when you want to convert some value to the other value. For example, if there is a nan or inf in our data, we must find a solution for this value because nan and inf are not good value in our data set. We can use a logical operator with a logical operation. Logical operator are and, or, XOR, and not. Or we can use and with the symbol or with this character, and XOR with this command, and not with this command. When you want to compute the not of a logical, you use this character. For example, we have this for b greater than or equal to 5. If I want to calculate the inverse of this logical value, I put this character before this operation, and the zeros are converted to 1 and 1 converted to 0. It is equivalent if I write the b lower than 5. Okay. Suppose that I want to find a value. Let me to run again the b. Suppose that I want to find a value that are greater than 8 and lower than 3. So I have two conditions in here. I must use AND between my command. So b that are greater than 8 and b lower than, for example, 3. As you see, there is no element that are greater than 8 and lower than 3. But if I converted it to OR, you will see that this value are greater than or it means that this condition or this condition. So the result is this and this and this. The logical operation are very application when you want to write if with each other. For example, if I can bring some examples for you from the AND and mostly used for if. When you want to check, as you see here, you use the AND between these two conditions, or in here it use the AND between these two conditions. It means that these two conditions must be satisfied. Or in here again and, in here again and. It mainly used when you want to write if statement. Or in here it used the not. And here it used the not. Use the lower. Or it use the not. It use in here or. Or means this condition or this condition is satisfied, this command will be run. Or in here it used the equality sign. In here we have equality, then or, and again and or again. It's a combination of all of them. it compared number of arc with 3, number of arc with 4, or it means that the number of arc can be 3 or 4. Then compare the is vector, the first input is a vector, yes or not? Is a vector, yes. The second input is a vector, yes. So this condition will be true or false. In here we again compare the quality, then there is an and between these conditions. Normal calculate the number of elements in the array if the number of elements is equal to 1 and number of r equal 2. So this error message will be shown to the user. The mainly application of logical operation are in the writing if. The complicated statement is constructed with this logical operation. There are two important functions in here that if you pay attention, we have one of them in this function. It is a any and all. What does this means? Please let me to bring the b again. Suppose that I want to check a matrix for a condition. For example, b lower than 5. As you see here, these elements are greater than 5. The output and the index of these elements are 1 and other are 0. If you want to write the condition that any of the element of b are greater than 0, then do a operation. In here you can use the any. So any of these elements, any of these are greater than 5, then the output is any b greater than 5. As you see, it shows the elements that are greater than c. As I said you before, when you apply a mathematical function to a matrix, it will operate on the columns. So any can apply to a vector, so it will operate on these columns. In this column, is there a 1? Yes, so the output is 1. Is there any 1 in here? Yes, so the output is 1. Let me to bring a bigger matrix. And let me to bring this matrix. If we apply the operation to this matrix, we can see that there is a 5 in here, so the output is 1. But there is not any element in this array that are greater than 5, so the output is 0. Or we can increase the threshold for greater than 5, so first these elements are output, and if you want to apply just on all of the elements, as said before, you can convert it to the vector, then apply, and the output is just 1. It is very helpful when you want to check one time that a condition is true. But if you want to check all of the elements are true, it's B. Let's bring the B and B greater than 5. In this matrix, just these two and these two are greater than 5, and other elements are 0. So when you want to check the all elements are 1, you use the all. I'll check for all elements, but there is one 0 in here, so the output is 0. All of them are 0, output is 0. There is a 0 in here, so the output is 0. Let me to bring another example for b that are greater than 3. B greater than 3. As you see here, the first column are 1, so the output is 1. The third column are 1, the output is 1. So if you want to check that all occurrence of a condition, you must use all. These two functions are very important and help you to write a good MATLAB program. Most MATLAB beginner use find for finding the index of an array in the condition, but I don't recommend it because the logical indexing, as I said you in many examples, can help you to find the index of the condition and extract these elements from the input matrix.